And we're back to wrap up 17-3, where we're going to take a look at this advanced problem where we take a certain amount of ice that's already frozen and below zero. We're going to melt that ice, bring the water up to the boiling temperature, boil the water into steam, and raise the temperature of that steam. Now, of course, this is more advanced. This is something for you pre-AP students that you should be able to handle. So the question says, how much energy in kilojoules is required to change 10 grams of ice at a -5 degrees Celsius to steam at 115 degrees Celsius? And it gives you this various specific heats and heats of fusion and vaporization. And so here's what we have. We're going to go back up to our map. Let's go ahead and color code this so we know what we got. We'll start with a deep blue because we have, again, ice. And in one step we're going to have to bring this up to the freezing temperature. Then in step 2 we'll go ahead and melt the ice. In step 3, and let's go ahead and do this in aqua, we're going to bring that temperature of the water all the way from 0 up to the boiling temperature. In step 4, we're going to boil the water into steam. And in step 5, we're going to take that steam at 100 degrees Celsius and bring it up to our final temperature. So let's go ahead and do that. Alright, so first things first. Step 1. We're going to take our 10 grams of ice and we're going to raise that up to 0 degrees Celsius. How do we do that? Well, Q equals SM delta T. The specific heat of the ice, it even tells you, is 2.1 joules per gram per degree Celsius. The mass of the ice is going to be 10 grams. It's going to be 10 grams throughout. And the temperature change, well, it's going from -5 up to 0. So that is going to be, the final temperature is going to be 0. You're going to subtract that from the initial temperature, which is a -5. So that's actually going to be a +5 overall, isn't it? And so therefore, when you perform that calculation, 2.1 times 10 times 5, you get 105 joules of energy. So that's how much energy is required to raise the ice up to 0 degrees Celsius. Now, it has not melted yet. Just because you added heat does not necessarily melt the ice. In step 2, we actually melt the ice. Okay. Now, we have 10 grams of ice. We have to change that into moles. Why? Because the heat of fusion is given in kilojoules per mole. Why is the specific heat done per gram and the heat of fusion done per mole? Well, you could easily change either one so that they match, but they typically don't. This is how they're typically reported. So you just have to take the extra steps. So we change the mass of the H2O into moles, and we'll know how many moles that we have. And now we can change that into kilojoules because 1 mole of H2O requires 6.01 kilojoules to melt, or to melt it. And so we take 10 divided by 18.02 times 6.01, and we have 3.34 kilojoules, which is the same as 3,340 joules. So we have now raised the ice up to 0 degrees Celsius. We have now melted the ice, and now we're going to take that ice and we're going to, I'm sorry, now it's the water at this point. It's water at 0 degrees Celsius, and we got to bring that up to the boiling temperature, which is 100 degrees. So, number 3, Q equals SM delta T. The specific heat for water is 4.18 joules per gram per degree Celsius. The mass is still 10 grams. That has not changed. And we're going to end at 100 degrees Celsius. starting at 0 degrees Celsius, that's a 100-degree change. And so we have 4.18 times 10 times 100 is going to be, so we're going to move the decimal a total of 3 times, so that should be 4180 joules of energy. Alright, so now we've taken the water and we've raised it up to 100 degrees Celsius. Now we have to boil the water in step 4. Step 4, we have 10 grams of water. We're going to change it into moles. Why are we going to change it into moles? Well, because again, when we're changing phases, they like to give it in as a per mole type of quantity. The previous one was done on a per gram basis. Again, that's their decision, not mine, but you can still do the calculation. So we have 18.02 grams per mole. The grams divide out. The enthalpy of fusion, the enthalpy of vaporization is 44 kilojoules per mole. And so now we have 10 divided by 18.02 times 44 gives us 24.4 kilojoules, which is the same as 24,400 joules. And lastly, we do need to bring this temperature of the steam up. We have Q equals Sm delta T. The specific heat for steam is going to be 1.7 joules per gram per degree Celsius. The mass is still 10 grams. The temperature change, well, we want to go up to 115 degrees Celsius. We're currently at 100. So it's going to be 115 minus 100. And so if we take 1.7 times 10 times 15, which is the 115 minus the 100, we get 255 joules. And so now, if we add up all of those quantities, can we get them all on one page? Yeah, almost. Yep, there we go. If we take all of these energies and add them up, the energy it takes to raise the ice up, melt it, bring the water up to boiling, boil it, bring the steam up to a temperature, we have 105 plus 3340 plus 4180 plus 24,400 plus 255. It looks like it takes 32,280 joules of energy to get the job done. That's a lot, but for those pre-APers, those are the types of calculations you should be prepared to do. Not every day, but that type of thinking should not be beyond you. Okay? In the next podcast, we're going to take a look at and wrap up 17.3, and we're going to be dealing with heats of solution. We'll see you next time.